This is the DJI Mavic 3 Enterprise, and I'm going to show you how to process this data on DJI Terra. And stick around until the end to figure out how you can win 3 free months of DJI Terra. All right, let's fly. So behind me here is a vacant pharmacy. It used to be a Rite Aid pharmacy, but now nobody occupies this building, and so we're being tasked with creating a high accuracy 3D model. So we're going to be flying our drone and collecting imagery using photogrammetry, as well as surveying ground control points in order to ensure high accuracy georeferencing. Now I set 5 ground control points, and 3 of those ground control points I used targets like this one. I left the link in the description for you. But 2 of those points were on hard surfaces, so I did photo ID using some of the utility structures since they were placed in the area that I would have placed a ground control point. In addition, I measured the rest of the utility structures on the site, getting 15 checkpoints to go along with our 5 ground control points. And taking a look here, I can see all of the points that we measured, everything from ground control points to checkpoints. And so using DJI Terra, I'm going to be able to georeference all of these ground control points as well as the checkpoints to help us with the accuracy of our data. All right, let's pull out our Mavic 3 Enterprise and set up the drone. Now, the nice thing about the Mavic 3 Enterprise is this. This is their RTK module that allows you to get RTK corrections for the trajectories of your drone. And it simply attaches up top like this. Okay, and now we will power on the drone. All right, so I've loaded up DJI Pilot 2 on the controller, and we're gonna start by going into the flight route, and then we're going to create a new route. And we're gonna select the area route, which will allow us to create a polygon around the area of interest. So I'm gonna select area route. Okay, here we are. This is the site. So I'm gonna select from the top, come down here, down and over. And I always like to select more than my actual area, just so I make sure that all of the data I need is covered in our area of interest. So this looks good. I'm gonna hit check here. I'm gonna confirm the drone that I'm using. So yes, the M3E, that's the Mavic 3 Enterprise. We'll say okay. And then I have the option to select an ortho collection or an oblique collection. An ortho collection means that the camera is actually going to be pointed down 90 degrees in a nadir position. Now this is good for 2D mapping, or if you're just looking for the terrain model, you can fly your drone with nadir ortho mode. But if you're trying to create a 3D model, like we are here for this vacant pharmacy, then we're gonna wanna do an oblique collection. Now in oblique collection, the camera will start like this in nadir, but it'll start to go back and forth. Back and forth. The oblique angle that we set will be the amount that this camera goes back and forth. And so while we're up in the air, the camera's going to do this back and forth motion, doing an oblique collection for our imagery. So I'm gonna select oblique. For gimbal angle, I'll probably set it to like 30 degrees. We'll probably fly at like 100 feet above ground level. I think that that's a pretty reasonable altitude. Under the advanced settings, I am gonna increase this to 80 degrees overlap and side lap. And yeah, everything else looks to be fine. I have no other issues with this. We're going to be flying this in 2 phases. So this right here is phase 1, and then this is phase 2. Each of these is going to take between 8 and 9 minutes. So in total, we're still gonna be under 20 minutes, which is pretty good. I'm gonna save this mission, and let's check a few other settings here. We're gonna make sure our RTK is fixed. Yep, we have good connection here with the RTK. So we're going to have corrections for our trajectories. And then in the camera itself, I'm gonna switch over to the shutter priority mode, switch our shutter to 1/1000, make sure we're on automatic focus center. Okay, everything else looks good. I like this, so I'm gonna go ahead and set the drone on the ground so that we can execute the mission. Okay, all looks good here. I'm gonna go ahead and hit the play button, check everything on our flight here. Everything looks good, and we're gonna upload the flight mission. And now, let's start. See you later. There it goes. And the drone is gonna head over to its first location, right over there. You can see now with the oblique measurements, it is pitching the camera several times to 30 degrees. So it's taking the shot, and you can't obviously see it in the sky, but in the camera here, you can see it, how it's pitching back and forth. That's the oblique measurements. It's trying to take it at different angles, and it's like sweeping back and forth the camera. And it's amazing how fast it's able to do that while flying at the speed that it's flying at. Okay, looks like it's getting ready to come back and do the second flight line now. Yes, here's the second set. It's gone over to its new starting point, and now instead of flying vertical lines, it'll be flying horizontal lines. And just to make sure we're doing some survey QA QC, our RTK is good. We've got a strong connection with 27 satellites. No issues there. Our trajectories are being corrected, so that's good. All right, last stretch here, nearly done, and looks like that's it. All right, and the drone is now landing. Here it is. All right, and now that we're done flying the drone, let's head inside so that we can process all of this data using DJI Terra. And welcome to the office. All right, now that we've finished flying our drone and we've captured all of these images, we're going to be processing them in DJI Terra. Now, when you first open up DJI Terra, you're going to select a new mission. And with new mission, it's going to ask you for the mission type. You have visible light, multispectral, and LiDAR point cloud. Since we're doing photogrammetry here, this is a visible light mission, so we'll select the first option. All right, now we need to come up with a name. I'm just going to call this Rite Aid Pharmacy, since that's what it used to be. Rite Aid Pharmacy. Okay. All right, now we've set up the job, so we are going to bring in our imagery that we collected using our Mavic 3 Enterprise. So up at the top here where it says photos, we're going to select add folder, and this right here is the folder with the images. So I'm going to select the folder, and now it's going to add all of the images. Everything is popping in right now. Very nice. So we can see all of the horizontal and vertical images that were taken based off of our flight trajectories. So that looks pretty good. So now that we've imported all of the images, we're going to go through the aerotriangulation settings. This will ask us typically what kind of processing we want to do, assign ground control points and georeference them, along with the checkpoints, of course, and setting our coordinate systems. So this is our horizontal and vertical coordinate system, and defining the geoid that we want to use for our orthometric height. So I'll open up aerotriangulation. The first thing it asks is for the scene, and the options we have here are normal, circle, and power lines. So the last one's pretty self-explanatory. If you're flying power lines, you'll select that one. Circle is if your trajectories look something like this, where you're flying around an object. This would be a circle scene, but a normal scene is what we have here, so we're just going to select normal. Computation methods, we have standalone computation and cluster computation. Cluster computation is typically used when you've got multiple computers processing a really large project. Our project is pretty small, so I'm just going to stick to the standalone. And under advanced here, we have our GCP manager. I'll come back to that. We then have our feature point density, and then there's a low and high option. I like to keep the high option, that way I have more points that I can work with. Distance to ground or subjects. This is basically asking us how far away the average object is from the drone. So for our mission, we flew at 100 feet above ground level, so I'll just put 100 feet here. And then for output format, if you want to output the aerotriangulation, this is like your tie points. You know, you can export it as an XML. I'm gonna go ahead and skip that. Now let's go back to the GCP manager. Okay, under the GCP manager, we have the option to first select our coordinate system. So our default coordinate system is just the World Geodetic System of 1984. I want to set it to state plane coordinates, so I'm going to change the horizontal datum to NAD 83, Michigan South. And then for the geoid settings, NAVD 88, geoid 18. Okay. And now we can import our GCP file. And there we go, it's right there, Rite Aid CSV. I'm gonna say open, and I've got all of my information. So I'm going to define the first column as the name, the second column as the northing, third column as easting, and then this is the elevation. Now these are our standard deviations, so I want to make sure we include those to help influence the point cloud based on how confident we are with the accuracy of our control points. So down here on the bottom where it says POS data accuracy, here we can change it and select custom accuracy. All right, and now I can come over here to this fifth column and define define this as the horizontal accuracy and the 6th column as our vertical accuracy. And then here in the 7th column, I have what the checkpoints are and what the ground control points are. There's no option to select here, but I know the first 5 points are ground control points, so I'll show you how you can distinguish between the two using DJI Terra. This all looks good. I'm gonna select import, and it's gonna bring in all of our points. There we go, all the points are now in. And if we look over on the right side, we can see our horizontal accuracy, vertical accuracy, along with the easting, northing, and elevation of each point. And now we're just simply going to georeference the position of each of these points in the imagery that we collected. Now the first one is a ground control point, so all I'm gonna do is see where it appears in each image. So there it is in this image, here it is in this image, and I will now select the position for some of the images. Doesn't have to be all of them. Now we've identified all of the ground control points. We have the checkpoints that we need to identify, but we need to make sure we switch them from ground control point to checkpoint. So I'll select point number 6, come all the way down to point number 12, and then where it says type, I'm gonna switch it to checkpoint. And now all these are checkpoints. And we'll go through the same process of georeferencing their positions in the imagery, just like we did with the ground control points. Now, I know some people are gonna ask, why is the reprojection error so high? Well, that's because we haven't done any of the aerotriangulation for the images. You could do the aerotriangulation first, get a relatively accurate point cloud, and then do your georeferencing. There's nothing wrong with doing that. I prefer to actually go in here and select the points first, because I prefer giving that information to the engine before it starts aerotriangulation, and that way I ensure that my ground control points are influencing the data set in the appropriate way. So both ways are fine, neither one is wrong, but this is the way I prefer to do it, and that's why you see this reprojection error. I promise you, after we do the aerotriangulation, that reprojection error will be very minimal. All right, now that we've finished georeferencing our ground control points, let's take a look at some of the output options that Terra can give us. So I'll close out of aerotriangulation and open up 2D map. This is your combined high resolution image with all of the images that you took with the drone. So I like to keep the resolution high. You could set it to medium or low if you don't really care about the resolution. Now when it comes to the scene, you've got field, mapping scenarios, and fruit tree. Field is going to be for, well, an open field. You know, nothing there, no features, no buildings, no nothing. This is just like an open field. Mapping scenario is going to be for city-like environments, which is similar to what we have, you know, lots of man-made features on the ground. And then fruit tree is for agricultural projects. Projects that have a lot of vegetation. Perhaps you're trying to do some kind of indexing work. Most likely you're probably going to use a multispectral sensor to do that, but you could do it with RGB. But anyways, for us, mapping scenarios is the most appropriate scene to use. And again, with the computation method, you have the standalone computation or the cluster. We're going to stick with the standalone. And then under advanced here, we have the option to change our coordinate system. I'm not going to change it. I'm going to keep it the same. We then have the map grid, which will basically separate your project into several different grids. So it's not one large image, it's like several little images. You then have the light uniformity, and this is good for if while you were mapping you had different lighting conditions. Let's say half of the site was super sunny and then the other half was really gloomy, and you want to balance the colors so it all looks like it was captured in the same lighting conditions. Then you can turn on light uniformity, and then haze reduction, as the name suggests. If you have a hazy environment and you want to kind of clear it out and make it less hazy, you would enable this. Under regions of interest, you would have the option to define a certain boundary. So let's say you flew way more than what you wanted and you wanted to just like create a box around a certain area. This could be a useful tool for you because it can cut back on processing time, processing power, and then making sure your file sizes are smaller because you don't have a lot of extra data. For me, I don't really care. My project size is pretty small. I would rather have everything and then clip it at the end after I've processed everything. So I'll skip creating a boundary, but you could do it here in Terra prior to processing just to save yourself some time and some space. Okay, and that is everything for the 2D map. All right, next we're going to look at the 3D model. Now again, resolution, you have high, medium, and low. I'll just keep this at high. We then have the scene. We have normal, circle, and power lines. We went through this in the aerotriangulation menus, so I'll keep ours set to normal. And again, the computation methods, I'm going to use the standalone computation. Under the output formats, we have the model. And this is the mesh of our project. So we're going to be creating a tin, and that tin will be output into some kind of 3D model. And you can reduce the model by a certain percentage. So the default is 50%. I'll just leave this at 50%. If you want a super detailed model, then maybe set it to 100%. We then have the option to enable point cloud. And here are some of the outputs that we can get. I'm gonna check LAS, and then I do wanna merge my output. So this will give me one LAS point cloud of the entire site, and not several little point clouds that I would have to bring in together myself. All right, this all looks good. We'll go to advanced. And again, we have our coordinate system information. I'm gonna keep it the same as our aerotriangulation. Now we have the custom model origin, which basically gives your origin point for your model a different position than the rest of the site. And then refine water surfaces will help you define surfaces under the water. This is pretty irrelevant for us since we're not flying anywhere near water, so I'll keep that off. Now under the ROI and the block, if we click here, we can again set a boundary for a particular area we want to work with. Let's say I don't want to use the entire site. I can adjust and set where I want to work with. And then the block splitting option allows you to break up the 3D model into different sections. So let's say we had several buildings and we wanted to break up each building into its own little model. You could do that using the block splitting option. We only have one building, so I don't need to do that either, but it's good to know what that option is. You can then enable work with DJI Modify, which is a 3D model modification tool. So this will seamlessly allow you to integrate your outputs into DJI Modify. All right, and then the last thing is applications. This is going to be what we use to annotate and measure our data after it's been generated. So everything looks good here. I'm gonna click on Start Reconstruction, and then we'll come back once the reconstruction is complete.
6.5 hours later.
All right, and the reconstruction is now complete. Let's take a look at our deliverables. So we'll start here in the 2D map. I can turn off all of our image positions. And there we go, we have our ortho image. But yeah, the resolution here is just incredible. This is coming out of the 20 megapixel camera on the Mavic 3 Enterprise. So very impressive results. And again, this was flown at 100 feet above ground level, so the higher up you are, the less resolution you'll have. But at a small site like this, doing 100 foot is achievable. So overall, I really like the resolution of this 2D model. And here's the 3D model. I will take a look and see how well this turned out. And my God, I mean, look at how crisp and clean this turned out. I mean, I can see the corners are so clean on this building. You can see how sharp and crisp the corners are. We can see all of the HVAC up top, and there's not a lot of noise. It looks like it did a really good job of filtering out the noise when generating this 3D model. So that's pretty impressive. I don't think I've ever seen any software create a 3D model like this. This is very crisp and sharp. It looks like I'm looking at just a picture. Even looking at the curves, how well the curves came out. I mean, that looks like a picture I took. It doesn't look like a 3D generated model. Look at the tree. The tree came out so clean. And like, if I zoom out, you can see the power lines too. Like, this is photogrammetry. This is not LiDAR. We're using the visible light engine here to generate this 3D model. And I'm seeing data here that I haven't seen in a photogrammetry model, at least not this clean. So yeah, I'm just impressed with the level of detail and how clean the 3D model looks. And so now let's look at the point cloud. So down at the bottom here, I'll switch this over to point cloud. And there it is. This is our visible light point cloud. And you can really see the power lines here. I mean, wow, look at that. You could actually do a decent amount of power line work. And I didn't even pick the power line preset. You know, if we did the power line preset, I think that it might actually look better. Maybe that's something we do in the future. But looking at the building looks great. Here, let me increase the point size so it's a little bit more visible. And yeah, you can see there's tons of points on the inside of the drive-through. The curb here in the parking lot looks good. If I wanted to take a single position, let's say I have a coordinate here, and let's say I want to see what the coordinates of this catch basin is, I can select the center here, and I'm given my easting, northing, and elevation. So that's pretty nice. If I wanted to measure the side of the building, I could simply select the line option, come over to, I don't know, this part of the building. Let's say I want to measure from here, go all the way down, and then let's measure this side, let's say here. Okay, so we've got a horizontal distance 129.66 and a vertical distance of 0.2. So our slope is 0.1 degree, which it's a flat roof, so that makes sense. But yeah, I mean, I get all that information just by taking a distance. Now, if we want to take the area of the building, we can select the polygon option. And I think that doing this on the point cloud is a little difficult. I could switch over to the model. And actually, this is a lot easier to work with because look how much cleaner the model is. So I'm actually going to come down to the bottom where the bottom of the building is. We'll start by selecting this point, come over to this corner, select this point. There we go. And I can come down here, select this point, come over to this corner down here, and then finish up in the back corner right there. All right, so we've got an area of about 0.254 acres. Of course, we know that area of a building is projected into square feet, so that's 11,064.24 square feet. Now, the projection area is the area based on the 3D model that exists. The fitted area is actually using the coordinates of the points that I selected. So it's two different methods to do the same thing, but it's good to understand how each one is calculated. And then if we were to pretend that this building was a stockpile, we can do volumetric measurements as well. I'll come over to volume. I can just select a couple corners here. Okay, and we'll wrap it up here. Looks like the mean plane for the base plate gives us a cut of 5,362.5 meters cubed, and the fill is 2.4 meters cubed. I don't know why it switched to metric, but it's giving it to us in metric. And then for the lowest point base plane, the cut volume is 5,434.62. Now, I know what a lot of people are wondering. Okay, this looks pretty. Thanks, Rami. How accurate is it? Well, that's why I have 15 checkpoints, and I'm gonna show you the quality report right now. And we've got all of the metadata about our process. So what we have here is horizontal errors are all within 1/100th of a foot for our ground control points, within 2 to 300ths in our vertical, and the 3D error is under 300ths of a foot, and our standard deviations are no more than 300ths of a foot. So that tells us the model fit beautifully into the ground control points. The relative accuracy is there, so we're looking good in terms of our own control. Now, when it comes to the checkpoints, from point 6 all the way to point 20, we can see the horizontal errors do not exceed 300ths of a foot. On average, the vertical errors are under 300ths, although there are a couple of spots like point 16, 18, and 19, where the error is about 500ths of a foot. Still, 500ths is really, really good for a checkpoint. And again, the standard deviation also under 500ths of a foot. So yeah, I mean, overall, I'm very impressed with the results that we got out of the Mavic 3 Enterprise as well as DJI Terra. Now, before we head out, I wanted to tell you about an opportunity to win 3 free months of DJI Terra. Currently over at thesurveyschool.com, our top performing students are receiving prizes which include hardware and software. And during the month of August, we are going to be giving away 3 months of DJI Terra to our top performing student. So if you are looking to take your surveying knowledge to the next level, consider enrolling into the Survey School, where you have an opportunity to collaborate with highly motivated members that are looking to advance their skills in surveying. Check out the link in the description, as well as all the products that I used in this video. Again, special thanks to DJI for sponsoring today's video. Make sure you subscribe to the YouTube channel, and with that, I will see you guys next time.